Assalamu alaikum warahmatullahi wabarakatuh. Welcome back with a new lecture with LCM SMS. In the previous lecture, we have discussed different parameters in the acquisition method in LCM SMS. Today's lecture, inshallah, will be around dwell time and how to calculate dwell time, and this is very important parameter in the acquisition method. Dwell time, which is the time spent acquiring specific MRM transition, to acquire specific MRM transition, or the time to get the peak for one MRM. Like this peak, to get this peak, this is the dwell time. After that, you will find pause time. Between each MRM, you will find pause time. Then another peak. Time to get this peak is the dwell time. After that, pause time. So the time to get the peak is the dwell time. You should know that longer dwell time can achieve better sensitivity and improve signal to noise ratio. But you should know also, when we select dwell time for each MRM transition, we should consider the peak shape. If we increase dwell time more than enough, we may get a broad peak, or we cannot get a sharp peak. Also, we cannot get the accurate measurement for the MRM peak area. Ideally, peak must be eluted 10 to 15 times. We should get 10 to 15 points to draw the peak to get an accurate measurement of its area. But 10 points is optimum number to have a sharp peak. Optimum number to have a sharp peak, 10 points, and accurate measurement also. So the peak to be drawn well and to get sharp peak, to get accurate measurement for the peak for MRM, we should have 10 points to draw the peak. As example, if the peak width is 10 second, peak width equal to 10 second. So every 1 second, there will be 1 point, and we will get for 10 seconds 10 points to draw the peak and to get the accurate measurement for this peak. Another parameter in acquisition method is the cycle time. In your LCM SMS instrument, you will find that cycle time is equal to the total scan time including pauses. The total scan time including pauses. So cycle time is the total amount of time spent monitoring the target analytes. If you analyze different analytes, to get every MRM transition, this is the dwell time, the time to get the peak, and between each MRM you will find pause time, but the total amount of time spent monitoring these target analytes is the cycle time. But also, to determine the cycle time, we should consider the peak shape. As we said in the dwell time, that 10 points is optimum to get the peak or to draw the peak for each MRM transition. How to calculate dwell time and cycle time, and this is the point of this lecture. From this equation, dwell time in second equal to pause time, second also, divided by n, which is number of points per peak. We will consider the number of points per peak also, multiplied to MRM transition, number of MRM transition, minus pause time, minus the pauses time. As here in this example, we have peak width equal to 10 seconds, number of points per peak 10 points, number of MRM transition 5, pause time 50 milliseconds. How much it will be dwell time? Dwell time, as we said, in second equal to peak width in second divided by n, number of points per peak, multiplied by number of MRM transition, minus pause time also in second. Dwell time equal to peak width 10 seconds divided by number of points, number 10, multiplied by 5 minus pause time 50 millisecond, should be in second, it will be 0.05 second. It will be equal to 10 divided by 50, 10 divided by 50, 0.2 minus 0.05 second, it will be equal to 0.15 second. 0.15 second, convert to millisecond to get the dwell time in millisecond, it will be 150 millisecond. 150 millisecond to get the peak. So the peak will be like this. We need 150 millisecond to get every MRM, to get the peak. And pause time, as we said, it will be 50 millisecond. And to calculate cycle time for this example, cycle time in second will be equal to dwell time, 150 millisecond, multiplied to number of MRM in transition 5, plus pauses time 50 millisecond, multiplied to 5 also MRM in transition, that 75 millisecond, and that 250 millisecond. So cycle time 75 plus 250, it will be 1 second. And we should consider 2 points. First, most of our chromatographic peaks on the x-axis expressed in minutes, but dwell time should be in milliseconds. So to get the dwell time, we should convert minutes to millisecond. As here in this example, 0.1 minute multiplied by 60 seconds multiplied by 1000, it will be 6000 milliseconds, which is equal to 6 seconds. And also for cycle time, for our cycle time, if we increase number of MRM, dwell time also will decrease, because the cycle time, same cycle time for all MRM, will be distributed for many target analytes or many MRM. So dwell time for this MRM will decrease if we increase the number of MRM for cycle time, dwell time will decrease. To understand this point, we have example here. By increasing number of MRM transition, as we said, dwell time will decrease. If the cycle time is equal to 3 seconds. For 5 MRM transition and for 40 MRM transition, 3 seconds equal to 3000 milliseconds. For 5 MRM transition, dwell time will be equal to 3000 divided by 5, which is equal to 600 milliseconds. When we increase the number of MRM transition for the same cycle time, became 40 MRM, 3000 divided by 40 will be equal to 75 milliseconds. We didn't consider here the pause time, but will be same. So for 5 MRM transition, we have dwell time 600 milliseconds, but for 40 MRM, we have only 75 milliseconds. If we increase the number of MRM transition, dwell time will decrease. Another example, and this is the last example in this lecture to calculate the dwell time. For 50 mass transition, you have cycle time 2 seconds, which is 2000 milliseconds, and pause time 5 milliseconds. How much will be the dwell time? We know that cycle time equal to dwell time plus the pause time. For 50 MRM transition, we have to calculate the pause time, which is equal to 5 milliseconds multiplied by 50, which is equal to 250 milliseconds. So here we should calculate cycle time without pauses to calculate the exact dwell time for each MRM. Cycle time without pause will be equal to 2000 milliseconds minus 250, which is pause time, which is equal to 1750 milliseconds. That for all of them, dwell time will be 1750 milliseconds. So for 50 MRM transition, 1750 divided by 50 will be equal to 35 milliseconds. So for each MRM, we have dwell time which is equal to 35 milliseconds for each MRM dwell time. that was the end of our lecture for today. In these two lectures, I have explained acquisition method, different parameters in acquisition method, and you can find also another parameters, but you should know that when you will build your acquisition method, you should change in these parameters to get the optimum results, to get the better sensitivity, better signal to noise ratio, to get your precursor ions, and also you will change in collision energy, declustering potential, whatever other parameters that we explained in the previous lecture, to get your product ions, precursor ion, product ions, to get better, to get the sharp peak. So you will change in these parameters by different numbers to get the optimum results that you want for your analytes. See you in the next lecture, inshallah. Assalamu alaikum wa rahmatullah.